now you feel very comfortable, at least looking at this diagram. Okay, this is the thing. Okay, whenever rod is there, what I said, length of the rod should remain constant. So component of velocities of the ends along the rod must be zero, must be equal. That's the one thing. With the help of that, I'll get the VB. You have to ask one question, sir. He didn't give velocity of point B. Why you are assuming velocity of point B like this? This is the most primary important part of the discussion. What is the question? Determine the velocity of slider block A at the instant shown. He's asking this particular slider. Its velocity has to be determined. Why the velocity of that particular circular gear rotates, no, rotating gear. It is clockwise, it is shown. So why it should be towards left only? Why not towards right? See, this is what your common sense should come into picture. This is what your common sense. If this moves up, if the point A moves up, at this block A starts rising up, tell me like what do you expect this point B? If it goes towards right, what will happen to the length of the rod? Will increase, no? For the length of the rod to remain constant, the point B must have velocity towards left. This is nobody will help you. There's no theory, nothing. A general idea of general motion of a bodies, connected bodies, one must know. Am I right? The slider A moves up. Then for the length of the rod to remain constant, the point B should move towards left. That he has not given. See, from I think first of all you start from here. As you start moving, so as this starts moving here, at this the I think what he is calling the gear rack. This called as a gear rack. As the gear rack, or in our language, we'll call plank. As the plank C starts moving. So as it starts moving, this will rotate like this, no? This will rotate, and the tooth which is here, what will try to drag this rotating gear towards left. As it starts moving towards left, so for the length of the rod to remain constant, the block A should slide up. Able to understand? If this plank C moves towards left, this will rotate here. So what this plank C will do, it will also try to drag the gear, rotating gear towards left here. So velocity of point B will be towards left. So the block A should move up. Okay, this is a very, very important part. Rest all mathematics. Okay, now we'll get into the first constant equation only for the rod AB. Let's get in the rod AB. VA cos theta, this will be theta is 60, no? So therefore this will be 30. So VA cos 30 should be equal to VB cos theta. So VB cos 60. Okay, there's a one constant equation, VA root 3 by 2 equal to VB by 2. Keep it in equation 1. No, any equation can be right further. So let's look at this point, these 2 points. Velocity of this point should be equal to velocity of this point, no? Because the tooth, they're in contact. That is the main idea. So here in our language, we say no slipping occurs. But here what happened? The tooth, the velocity of this tooth and this tooth should be same. So based on that, it should be equal to VB plus R omega B. What is R? R is this one. equal to VC. So VC, value of VC we know, R we know, omega B we know, we'll get the VB. Value of R 75 millimeter, no? So 0.075, omega B 10, VC is 5. 4.25 meter per second. Put 2 in 1, we'll get the velocity of E. Anybody value VA?
17/4√3.
2.45.
It's a 2.45.
Okay, I think for our in advanced exam, they may object. No, they may change problem like this. They'll ask you. Okay, don't bother. Just carry on. No slipping occurs between this disc or something. Will say between the plank. Then anyway, you're going to write it here. So that's why I gave both the diagrams. I wanted to discuss only for this, but the way in advanced exams or if you look at the books, no, we don't have diagrams of this one. So they may convert like this. They'll ask you what is there in that one. They don't bring the word gate, so they'll call this like a spherical rigid body. There's a plank, there's a block which can slide along this one. Either way, they can test you. Huh? Need not to be always with this diagram. Hmm? Yeah. I will. Anyway, I think this you are quite familiar.